My name's Paul Chesser. I'm with Climate Strategies Watch. You don't need to know a whole lot about me other than that I'm a one-man organization, and what I've been doing is tracking the state global climate change commissions in the states, following what they're doing, the policies they're trying to implement, and the liberal advocacy and alarmist advocacy groups that are funding them and are behind them. But this panel is about impacts, and today we have the luxury of plenty of time for our two speakers. We have Stanley Goldenberg and we have Benny Pizer, and Mr. Goldenberg will be going first. And to introduce him, from his bio, we've got Stan Goldenberg is a meteorologist with a hurricane research. What does AOML stand for?
Atlantic Oceanographic and Meteorological Laboratory.
I'll trust that you all heard that. And the National Oceanographic
and Atmospheric Administration.
and an atmospheric administration located in Miami, Florida. His hurricane-related research has included developing and implementing significant improvements to one of the earlier numerical hurricane track prediction models used by the National Hurricane Center. More recently, he has examined the various climatic factors that influence the variability of hurricane activity in the Atlantic from intraseasonal to multidecadal timescales. In particular, he has done extensive research into the physical mechanisms responsible for the connection between El Nino and Atlantic hurricane activity. And he also goes up in airplanes. He's participated in numerous research flights into nearly 20 hurricanes aboard NOAA's P-3 aircraft and on many of the NOAA G-4 jets flights. His interest and experience in hurricane disaster preparedness was greatly increased when his home was destroyed as his family experienced the full force of Hurricane Andrew in 1992. His family's Andrew experience has been featured in TV specials done by National Geographic, PBS, and the Discovery Channel. He's authored several scientific papers and has been a regular speaker at numerous hurricane preparedness, insurance, and scientific conferences. Would you please join me in welcoming Stanley Goldenberg?
Thank you very much. It is quite an honor and privilege to be here. I found out about this very serendipitously. I mean, Cal Beisner, who I happened to end up on a panel on a national radio program with about a month ago, emailed me about 3 weeks ago, or 2 or 3 weeks ago. I think it was Valentine's Day, I found out, and checked into it, and then ended up being a speaker. And I'm thrilled because, as I'll say here, I have been looking into the overall global warming area. When we deal with hurricanes and global warming, most of the people involved who will write papers on this will not dare to touch the sacred idol of anthropogenic global warming. They're only dealing with the relationship between whatever is causing the warming, between that warming and hurricane activity. But I am becoming more involved in looking into the overall picture, though that's not the main subject of my talk today. I'm going to mention a lot of personal things because I really consider that some of my authority and experience on this comes from the different things I've seen personally about hurricanes. And it's very different getting up close with them. I was just talking to Jason Dunyan, one of the world's experts on the Saharan air layer, and he was saying the other day, there's nothing like going out in the storm. You can look at the data till you're blue in the face, you can look at all the tracks, everything from the plane, but somehow when you're out there and immersed in it, it makes a difference. I know Dr. O'Brien, who was my major professor at Florida State University about 30 years ago, and I always remember you used to send all your oceanography students, even if they were modelers, he'd make them go on a cruise to see how they collect the data, because you've got to know how they collect the data to understand how much it's worth and what trouble people go to collect it. And we, of course, risk our lives going out there and flying into storms. There have been near casualties. Thank you that they haven't happened. But, you know, it's not exactly a simple business to go out there and fly. People say, how do I do it? I say, we have good pilots. But I'd rather be on one of those flights than a commercial flight any day. But anyway, the original talk of this, name of this was the improper use of the historical database to link global warming with increased tropical cyclone activity. I meant to ask, do we have a pointer, a laser pointer? If not, I'll survive without it. No, okay, I thought we were. I got to get my own. Heartland gave me a little simpler title there, the mythical link between hurricanes and global warming. I'll say mythical, robust, strong link. I mean, maybe there's a link out there, but we're not seeing it. Let me deal a little bit with the overall global warming picture. And one thing I believe when we're talking to people is to understand the importance of definitions and terms and the confusion of terms. You know, what we're really talking about when we address this whole issue is AGW, otherwise known as Al Gore warming. Anthropogenic global warming, man-made global warming. We're not talking about global warming. When they say global warming is doing this and this, most of those people are talking about AGW, not just global warming. So GW is just simple global warming. It doesn't necessarily equal global warming. It doesn't necessarily equal climate change. I mean, several people have alluded to that. That's absolutely absurd to start calling it climate change. That's stealing a term that is so meaningful in many different areas and factors and time scales and using it for this whole agenda thing, which is utterly absurd. Just because the Earth is warm about 0.7 degrees Celsius in the last 100 years does not mean anthropogenic global warming. I know I'm preaching to the choir, but this is summarizing things that are significant for me. Just because climate change happens doesn't mean AGW. Just because there's disasters doesn't mean AGW. I mean, they try and attribute everything. How many of you heard when the tsunami happened? AGW, okay? We had recently something in Miami, and they said there's more animals in the animal shelters because of global warming. Honestly, why? It's a longer mating period. I mean, they came up with everything. I know they'll be blaming divorces on AGW. It's true that increased greenhouse gases such as CO2 cause increased warming. I mean, that's mathematically sound. The issue is how much. I mean, is it even a significant amount? Is it even something you can measure? Is it anything like what they're talking about? And can you separate from the natural cycles? And the inconvenient truth, and most in the media are speaking of CAGW. I've only learned of that phrase recently. They're talking not about AGW. They're talking about catastrophic global warming. If it was just simple AGW, they really wouldn't care. That's saying for scientists. But this is catastrophe about to happen. So hurricanes fall perfectly into this category because hurricanes are the greatest storm on Earth. I have a whole big talk on that. I mean, the scale and the magnitude of what they do and disruption to communities and cities. And you heard how many got killed in the tsunami, the cyclone, which is another name for hurricane there in the Indian Ocean, that killed hundreds of thousands in Bangladesh years ago. I mean, these are massive, massive systems that can do incredible damage, incredible disruption. Again, this is just intro on the overall area. Things that I found significant when I deal with people and talk to people is what are the factors causing the false public perception of the AGW issue? Media, censorship, bias, and distortion. How many do we have here from the media? Can you raise your hands? Okay. I love you all, and some of you all are great. Okay. I have the least trouble with science reporters. Including Andy Revkin, who might be leaning to one, he's here today, and might be leaning to one area on the overall issue, but when he deals with us on the tropical storms and global warming, he's able to understand what we're talking about. Madeline Nash from Time Magazine also did an issue with me in Smithsonian. I mean, some of these are really great to work with. Then all of a sudden you get some of these regular reporters or editors or people like that who have an agenda, and it doesn't matter what you say. I'll talk more about that in a second, because that's significant. You've got to understand what's going on with the media, and the public has to understand. I'm talking about how do you talk to the public, how do you explain it to kids in your middle school, and to parents and others, because they say, let me tell you, back in 1995, when this huge upswing in hurricane activity started in the Atlantic, I mean, talking from 4 of the slowest years on record back to back to a year that almost was comparable to 2005. Most Americans don't remember it because it devastated the Caribbean. It didn't devastate the United States. We had a few landfalls. But when that happened, there was a big front page article in the Miami Herald, and a neighbor was telling my wife, oh, this is all from global warming. Now, she really meant AGW, right? But this is all from global warming. Well, I said, no, it isn't. Oh, yeah, it is. My husband is a hurricane meteorologist. He studies this stuff. He says it's not from global. She says, but it was on the paper. I only know what I read. I mean, are they supposed to really know? How many people in the public know that the Miami Herald can have something totally erroneous and deceptive on the front page? Big. Okay, that's a big issue. And by the way, they had not a single interview with a scientist or article or something. They just decided this was global warming. The perception now that it's warmer now than it ever has been before, and there's been many talks on the hockey stick in the medieval warming period. I won't take more time with that. By the way, regrettably, my slides were not duplicated ahead of time. They might have some copies available for those who would be interested. By tomorrow, if you want to check this room, there might be some in the back. If not, you can contact Heartland Institute later, because I'll whiz through some of this stuff. The other thing that affects people is short individual memories. When we had a barrage of hurricanes hit the central part of Florida, 3 storms crisscross right near Orlando, dear precious Disney World land and Universal and SeaWorld and everything. And in 2004, they were like, it was easy to say global warming because everybody was freaked out. They never seen anything like this before. Well, yes, they had. In the previous active era in the 60s, you saw storms crisscross the center. But in the 60s, what was in the middle of Florida, with all due respect to the citrus farmers and the wiki-wishy mermaid thing that was there? I mean, that was before Disney World. And before all this other stuff was there. It's a totally different place. And the buildup along the coastline and even interior, and still, you can get a Cat 3 hurricane strength hitting Orlando. If it's strong enough at the coast, if it's moving fast enough, it can be Cat 3. Andrew was Cat 3 when it emerged on the other side of Florida. It can maintain its strength if it hits strong enough. And I guarantee you the storms they had would be nothing compared to something like that hitting the central part of the state. But people forget. You know, they say it's never been this cold. And they look at some records and somebody says, and we know how the records can be deceptive because of the non-homogeneity of the database. Other errors, the inconvenient truth. I mean, this film is responsible for more deception. It's shown in theaters, schools, talks. Al Gore trained 1,000 people to give his talk, and each of them made a commitment to give it 10 times. He had like a boot camp. I spoke opposite one of those people, who thankfully wasn't brainwashed, as he listened to what I had to say, especially about hurricanes. She didn't dare say too much. But she listened to the other stuff I had to say as well, but she said, oh, yeah, I want to know because I have to give this talk 9 more times. So he had this incredible boot camp to teach these people. So thousands and millions of people are seeing the talks and the movie and everything. And why should they think it's a lie when the title is Truth? Okay, you know, uncomfortable, but it's the truth. And many of the impacts in Inconvenient Truth are not even, I mean, it's easy to show they're not related to global warming. It's full of scientific errors and misrepresentations. And those of you who don't know what Monckton did as far as England and helped the truck drivers sue the schools there, and in the schools there at least, they can't show it without a list of disclaimers. And you can get that on the Science and Public Policy website. And the DVD talking about those. But now at least they show it. They should do that in the American schools. I'm itching to go into my son's high school and give a talk on hurricanes. Because once I get in there, they can't stop me. And I will, because I'll talk about certain issues. The other thing, many findings depend on the global climate models. The models are imperfect, garbage in, garbage out. They don't have sufficient equations, and they never have sufficient observations. There's no way they have sufficient observations for certain scales. But you can't have an infinite number of observations go into these models, or an infinite number of grid points and everything. They're always going to be imperfect. They can't. One of the most important things in the atmosphere, especially dealing with hurricanes, is clouds and the precipitation and that's so complex. They do what's called parameterization, and they just come up with some numbers and fudge factors and things to kind of, you know, give a touchy-feely feeling for it. I mean, they cannot do. I'm not saying models are worthless, but they've got to be used with tremendous grain. So reality is very different from what models say, and they tune them and tune them and tune them. And I work with one of the hurricane track forecast models, and you can get it just running really great, and then you launch out in the real world, you know, in the future with other data, and all of a sudden, what happened? What happened? So. That's the issue. And just because this is so key, for those of you who are not scientists, thus just because it's published in the refereed literature doesn't make it true. Even prestigious journals of science and nature, there's more falsification in science and nature probably in the other journals. The editor printed a whole sheet on this one time, and he's an op-ed piece, and he said, you know, we're really concerned about the growing amount of falsification because it's so prestigious to publish in those that people will do anything to get into it. So it's still nice to get in. It has a big audience, but it doesn't make it good, and the articles are so short you can't get into all the real information anyway. But publishing is a good, little bit of a control, but it does not make it right. I just want to talk about my media experience for the next slide. I've been in numerous TV specials. There's dozens of TV specials shown all over the world in classrooms, thankfully. Cyclone, National Geographic, virtually every major name. I've been interviewed hundreds of times, and of course there's many other people in the conference here who have much more experience than I do in these areas. But I mean, I've been on CBS Nightly News and World News Tonight and Today Show and Fox and MSNBC. I say all that not to boast, but it's gives me somewhat, I'm cut off at the bottom there, somewhat of an understanding of how the media works and how it interprets and presents the data to the public and to government. And I've seen it, firsthand. I've seen how it gets filtered in the sound bites, and anybody here who's been interviewed knows how that goes. Why is the media coverage so inaccurate for you media people? And why is it inaccurate? I mean, sometimes it is accurate, but why is it inaccurate when it is? Ignorance. They don't know. They just simply don't know. They don't understand what you're talking about. Sloppiness. They don't want to know, or time constraints. They just don't care. Many times they'll put stuff in there and they know they haven't fact-checked and done all sorts of things. They just put it in there because they don't really care. It's their article. The boss doesn't care. Why should they? Biases. They think they know, or their Weltanschauung, their worldview, their colored glasses affects it. Everybody has biases. Everybody, if someone came in the room and shot 3 people here, your bias would be, that is a bad thing. That's a horrible thing. Maybe there's some terrorists that would be jumping up and down. When 9/11 happened, we had certain Muslims go into a Lebanese bakery and was dancing and handing out candy. When 9/11 occurred, thankfully the owner threw her out. Okay, but there were people celebrating. Yasser Arafat knew a lot of Palestinians, excuse me for getting political for 1 second, but had a lot of Palestinians that were celebrating, and it got on video. And he right away tried to do damage control with that. It's their worldview. And sometimes there are flat-out, blatant, deliberate lies. I've seen all of these in my experience with the media. Thankfully, not many deliberate lies, but I have seen them. Some people on our hurricane flights make up such fiction. I say, were they on the same flight we were? I mean, sometimes it's benign. Who cares? But sometimes it affects people and affects policies and affects lives. And absence of malice. I think of that old movie with Paul Newman and Sally Fields. I mean, sometimes it affects people's lives. And like we're talking in this conference, people die. People die because of some of this stuff. People die because of bad weather forecasts. We have a problem with the National Hurricane Center. Now, I work for the Hurricane Research Division. That's a cousin organization to the Hurricane Center. We're the research arm of NOAA. They're from the operational, but we work closely with them. And we're concerned sometimes AccuWeather came out and did a contrary forecast of the Hurricane Center because they think they're better. Well, maybe it was even better, but it caused such confusion to the public. And if you mess up evacuations, you could cost lives. And sometimes bad media coverage affects lives. What's some of my experience? I know most of you can't read this, but I'll say that I've interacted with numerous hurricane scientists through the years, especially with the permanent visiting scientists of NOAA's Hurricane Research Division. Many of these are among the top in their areas of expertise. I mean, in our hallowed halls there, listen, we're government scientists, music and drum roll or something. And I remember one time a certain professor that I used to have back in the 70s said some negative thing about government scientists. But the fact is, in our lab, I mean, we have meticulous, analytical scientists who care about what they're doing, and we have high-quality work and high-quality research coming out of that place. And we interact with scientists at the Hurricane Center. I've interacted for almost 3 decades. I mean, I watch, I see this stuff. I mean, day by day, we used to have map discussions when we were co-located in the same building with them. I see just day after day, it affects you. You see all these little nuances that you could never pick up reading 1,000 charts and 1,000 papers. And I still remember my first hurricane, I saw them forecast, Hurricane Allen, which was a Cat 5 storm, and then a Cat 3, and then a Cat 5, and then Cat 3, and it was my first storm I ever flew, and I'll never forget the Hurricane Center. It's too early in August. This can't develop. It kept getting stronger. It's not going to develop anymore. It kept developing. It was going very fast. It's not going to keep going fast. It's going to slow down. It kept going fast. It's going to turn to the north. It kept going straight. I mean, the storm defied all of their stuff, all of their predictions, and thankfully, just before landfall, weakened from Cat 5 to Cat 3 and hit Brownsville, Texas. But you learn a lot. My personal research with hurricane forecast models, but mainly hurricane climate studies. And I have some very prominent papers that have been published in that field. Not as many as others. I'm a slow writer. But participation in the field program, the hurricane field program. I've flown in numerous storms. I don't know, the 20 is an old number. I don't know how many I've flown, but I know I've gone through the eye over 100 times of different storms because I have a 100-plus eye wall patch. On my jacket. I've gone on the NOAA P-3 Orion, some of those heavily instrumented aircraft in the world, and the Gulfstream 4 aircraft. and operated all sorts of different instruments on the plane. Also, the Hurricane Field Program, interactions with the Hurricane Centers allowed me to see firsthand how the data is used to determine the position and strength of hurricanes and how they're gathered and quality controlled and finalized. I'm part of the NOAA Seasonal Hurricane Outlook team, forecast team. I was the first lead author on that. So we look at all the climate factors every year, and we interact and have all these conference calls. We learn. And we learn how much we don't know. The forecast basically busted 2 years in a row. Those are the years we learn the most and really go into why did this happen? Why did this happen? What are we missing? And also on the ground, you know, I've looked at hurricanes in the air, on the computer, and on the ground. Experienced the full brunt of Category 5 Hurricane Andrew, one of the only Cat 3 U.S. landfalls in the past century. And I got the strongest wind area from Hurricane Andrew, plus extra winds. So I'll show you a picture in a minute just for fun. Okay, hello, turn. There we go. These are aircraft, and I might have hit the button too many times, but they penetrate the hurricane's eye from about 1,500 to 22,000 feet and fly up to about 10 hours, 3 radars. I mean, so many instruments, I don't even know probably what a third of them are, and we keep adding more and more. And it's not just, you can't throw an instrument on. You've got to calibrate, you've got to work on it, you've got to do research, you've got to analyze it. So it's a lot of careful stuff that goes into what the Hurricane Center finally gets. And this is inside the eye of a strong hurricane, Hurricane Diane in 1984. And just awesome beauty from sea to sky. After being bumped around, you get in that. If anybody want to guess how high that eye wall is, it's about 10 miles high. And you can see the striation just going around as the winds cycle around. And you never know that what's in that wall can destroy a city. I mean, this was just an awesome, awesome hurricane to go through. All sorts of additional data is being added to the planes. In 1997, we started using GPS drop wind sondes. And this revolutionized how we could look at hurricane wind structure in the vertical. This is just 10 years ago. I mean, we're just constantly learning this stuff. It's like a weather balloon, but it's dropped down from the aircraft, and it measures temperature, humidity, pressure, and winds from the plane to the surface. And it gives vertical soundings of the atmosphere over the ocean where there's no standard weather odds. I guess I'm going to have a lot of slides cut off on the bottom. I don't know why. And we use it to measure the hurricane's large-scale steering environment. You will excuse me if I whiz through certain things and get to the meat of this. Anybody can look at the talk later, but I just want to touch this. I found out with such short notice, the hardest thing is to winnow a talk down, and so I'm just working on that. It's resulted in substantial reduction in track forecast errors, but also we drop it in the eye wall of the storm. And for the first time, we were to get a full vertical profile of the wind, and we saw things we had never seen before. I was there when they made the decision to drop the first one of these in an eye wall. You know, it was like one of these serendipitous things. Mike Black, sat there and said, James, what if we try one in the eye wall? We weren't going to do that. He said, yeah, let's throw a few in the eye wall. And I mean, it blew us away. And within months, the Air Force was routinely dropping it from their planes, and the Hurricane Center has been using it ever since. I mean, it just totally revolutionized the surface. And it has proved to be ground truth to measure other types of instruments that measure the winds of the surface. Here's Hurricane Katrina, Cat 5, that hit New Orleans as a Cat 3. But it's a little close-up of the eye, and this is a closer up of the eye, because I was there in the landfall flight. Happened to be right there in the landfall flight, happened to be on the instrument processing the dropson winds at the surface. And the Hurricane Center was saying it was a Cat 4, everything was on the plane was saying Cat 3. And the Hurricane Center has their reasons, and they see more data than we do, and I was very polite, but 2 or 3 months later, they changed it to a Cat 3. But we see all this stuff just up close. What was unusual with this was the pressure was so low. Those of you who understand about pressure-wind relationship was around 910, 909 millibars, and that's Cat 4 or Cat 5. And the Hurricane Center just could not fathom that was only a Cat 3, but sometimes the distribution of the pressure is different, and this indeed was a Cat 3. And this was our little crew with Chris Lancy, who you hear his name a lot in this talk and other talks. He's a hurricane climate specialist, myself, Mike Black, and Peter Dodge, who are radar experts. Katrina's damage. I want to ask you all one question. In Al Gore's movie, this was from global warming, AGW, right? Okay, can someone tell me in one word why Katrina was a disaster in New Orleans? One word. What? Levees, thank you. Yes. The result of global warming, it was levees. That was the only reason it was a mega disaster. The fact is they got the weak side of the storm. That's how you get the worst damage in New Orleans. You have to get the weak side so the wind comes from the north and can damage the levees. It was Mississippi that got the strong side and a 30-foot storm surge. They're not even in the news much anymore. They're still rebuilding. They're just a total mess there. They were just wiped out. But New Orleans got filled like a fishbowl. And in fact, the first hurricane special I was in, Cyclone, from National Geographic, well worth getting for schools and stuff. After my story on there, they had, what would happen, it was 1995, what would happen if New Orleans got hit? And they just went into the whole scenario of what would take place with that. So it was very, very 10 years early. It was the levees, it was the levees, it was the levees. And it could have happened in a very slow year. It just took one storm. It didn't care that it was one of the busiest years on record. It just took one storm. My personal Andrew experience, like I said, just what I've gone through and seen this stuff. Because I remember when I was in Andrew and I talked to one of the wind experts, Mark Powell at our lab, and was telling him and me and someone else who were in the worst winds were saying what we thought the winds were, not that we had a little anemometer, but from different things. He said, no, you're emotionally biased. And we watched with glee as he did all his detective work and pulled in all the data, and the winds went up and up and up and up, and it came to about what we thought it was. But this is we call this the bagel that ate Miami, and I'm actually getting some handouts. They were supposed to be shipped in today, and I'll put them on the back table too. It's just some Gosh Wow Hurricane handouts and a few of these and some other sheets. But that's where my house was. So as the storm moved west, I went through the North Eye Wall, and there's also right there is Burger King Corporation, and they had shutters in their original building plan, and they dropped it as a cost-cutting measure. We call that a whopper of a mistake. And they were devastated. But there's Doctors Hospital. The reason, and where NHC was only a few blocks away, significance because I had my first girl, my fourth child, on the night of Andrew. 12 hours before, 4:35 p.m., 12 hours before my house was destroyed, Pearl was born. She'll never forget it. And that's what's been all these specials. And yes, my hair is darker there. But my wife said it was the very easiest birth. Nothing was happening then. It was a very small storm, so nothing happened till around midnight or 1 in the morning. But I went home to be in my house. And this is what my house looked like. Those pictures are on my website. And this was concrete block. In the lower right, that's a concrete block, steel rod reinforced gable end. It was ripped in pieces. The entire roof ripped off in one piece. And there's actually the roof kind of smashed against a neighbor's house. It just flew off in one piece. This wall right here fell on us. And I was there with my 3 sons, my brother-in-law, sister-in-law, and their 3 sons. And we were not, this was not storm surge. Most of the damage in Andrew was not storm surge. So that's the wall that fell on us. We were in like a little cubby hole. And the interesting thing was the refrigerator held up that wall by 1 foot on the counter on the other side, or that would have come smashing down on us. It turned out in hindsight to be the safest place in the house. It wasn't comfortable. The stove was on my back. I was on my knees over my kids. I won't take more time with that. It was pretty heavy-duty experience. But you learn just being in the middle of it. This is Naranja Lake's condominiums where the highest concentration of deaths occurred. We had someone from our lab there. This is a mobile home complex. You notice that a few survived. Ted Fujita used to joke that, you know, if you have them on a lazy Susan, you could face them along the wind. Somehow survived. These were wiped out. There's no more mobile home parks in those areas anymore. This is, by the way, the property damage. And the yellow is the area that the biggest devastation occurred. If the storm was just 20 miles to the north, it would have been much, much worse. And I always envision if we get another Andrew and it hits that way, I can see them saying, look, 15 years later, it's much worse. Must be global warming, yes. Because the property value, it picked the least populated area of all of Dade County and still was one of the costliest natural disasters in U.S. history up to that point. Could have been much, much worse. Sometimes these are changing slow. Just those who are not familiar with the Saffir-Simpson scale, category 1, 2, 3, 4, 5. Andrew was a Cat 5. Now, before I get into hurricane climate in the last part of this talk, is I just want you to understand some terms, because frankly, I don't just want to throw a bunch of equations and slides and figures and graphs at you. I want you to walk away understanding something about my area of expertise. And to look at hurricane climate fluctuations, you have to have a measure of the activity. And there's all sorts of measures of the activity. There's depression, which is basically we were saying that's when it developed. That's when it first formed. These are all tropical cyclones, depression and above. That's another name. Hurricanes is just when it's a certain strength. Then you have tropical storms, hurricanes, major hurricanes, which are category 3 and above. And then you have measures like the number of storms, the number of hurricanes, the number of major hurricanes, how long they last at each of those strengths. But our favorite variables to use for Bill Gray's group and for the NOAA group are measures of overall activity for the season. So we combine the strength and duration, or Bill Gray combines the strength, duration, and numbers, and come out with these. The net tropical cyclone activity, NTC, where 100% is average. So 200% is twice the average. A year like 2005, I think, was about 285%. A year like 1983 was 32%. It can be that much diversity. They still had a category 3, $2 billion hurricane that year. And that just combines all the factors. Then we have, for NOAA, we use ACE, the accumulated cyclone energy, which is the sum of the max wind speeds every 6 hours for all the storms for the season, or for a period, whatever you're measuring. And it's amazing. These are calculated so entirely differently, and yet they're correlated like at 95% or something. They just really pick up kind of the energy of the season. You have all sorts of different time scales. I know you can't read all the stuff on here, but you have monthly time scales. You sometimes have a few weeks that are very active from something we call the Madden-Julian oscillation, and a few weeks that are less active. You have yearly time scales. I mean, it starts in June, peaks around August to September to October, and then peters out by the end of November, usually, except in 2005. And then you have things interannual like El Nino. And you have El Nino, which may be on the order of 2 to 5, 2 to 3 to 7 years or so. Then you have multidecadal. You can have longer term, and who knows, longer terms that we're not aware of because we don't have a good enough data record. If you combine these two charts, though, you get what's at the bottom, which is very close to what the activity looks like, just a combination of a quasi-El Nino type signal and a multidecadal signal. You can be up for a few decades, down for a few decades, and vary from year to year. I mean, people understand with 2006 and 2007, first of all, 2007 was not a dead year. There was 2 Category 5 landfalls. It was more active than most of the years from 1971 to 1994. And it was still an average year according to how we measure things. But the fact is, just because we say things are active doesn't mean every year is going to be active. I look at the variability in the Atlantic as like a sluice gate. And frankly, the way publishing works, in my 1996 Goldenberg-Shapiro paper, we were talking about the relationship between El Nino and Sahel rainfall to major hurricanes. And somewhere in there we came up with the term main development region. It wasn't even in the abstract. It wasn't even a main point of the paper, but it's probably the most referenced thing from the paper now because everybody looks at this main development region. But I look at it like a sluice gate that opens and closes to allow the storms to come through and develop. So a normal season, you have about the same number of easterly waves coming off of Africa each year, but how many develop or how those climate signals look in this main development region. And you have a year like 1983, which was an El Nino year, no activity at all, not a single depression or tropical storm in the tropics. Just 4, I think it was just 4 storms the whole year. So that sluice gate was just totally closed. Then you have a year like 1995, this was long before we had 2005, that I made this chart, when for 2 weeks every single wave developed, was named. It was just storm after storm after storm, lots of stuff in the main development region. So things vary a lot from year to year. What controls the sluice gate? Okay, you all understand everything on here, but basically there's a lot of different climate factors, just like you've heard in many other talks. This is complicated. It's just not one factor or one particular thing, but you look at the East Pacific sea surface temperatures, which are really related. We're talking about ENSO, El Nino, and La Nina, and how does that affect the Atlantic? It's really through vertical shear. The vertical shear, which is one of the main things that affect things, is the difference, if you've heard that term, the difference of the winds in the upper and lower level. When they're weak, when that difference is weak, the storm can organize in the vertical like a chimney. When the vertical shear is strong, you have a big difference, you can rip the storm apart. And it's probably one of the key factors. You can have the ocean almost boiling, and if you have strong vertical shear, you're not going to have a hurricane. this is what the NTC, net tropical cyclone activity, has looked like from 1950 to 2005. And the red is above average, green is below average. You can see this, there's this 20-year period here, 25-year period. Now, this is where we consider reliable data to look at the whole basin is really from about 1944 to the present, because you started aircraft reconnaissance. We just simply don't go before that. Not that we trust all the aircraft reconnaissance data at the beginning, but it's just at least you can get a glimpse of what's happening. And you can see these years, then you see this 24-year period. The dashed line here is hyperactive. Above that is a hyperactive year. Not a single year for 24 years was hyperactive. Then we hit 1995 and the activity just woke up again. We see this multidecadal signal. We see it correlated with what's called the Atlantic multidecadal mode, or other people call it Atlantic multidecadal oscillation, the AMO. And it's basically a signal, a signature. Yeah, he actually said I could have a few more of his minutes, so I'm going to take them. But it's a signature that you do by empirical orthogonal function analysis, which I won't go into here. But basically, you pull out these modes of variability. And so you have it getting warm in the main development area for a few decades. This is the signal. This is believed to be driven, Dr. Gray, I believe, will talk about this tomorrow, driven by something called the thermohaline circulation. There might be other explanations. But this is the time series, going way back to the 1800s, that you have warm for a few decades, cool for a few decades, warm for a few decades, cool for a few decades, and we see the tropical cyclone activity mirroring this. Now, the fact is, I did a study with Lloyd Shapiro years ago that the sea surface temperature under the storm is not the primary driving influence for climate change. It's a very small percentage. It has to be what's happening in the atmosphere. Well, it turns out the Atlantic multidecadal mode is associated also with what's going on with the vertical shear. And here's just vertical shear, several decades. Actually, up is favorable. I flipped this, so that's weak shear. So you're up. Weak shear for several decades, which is favorable for activity, then down, and then up again. Now, what happens when we have this multidecadal increase, which happened in 1995? The major hurricanes account for most of the damage and fatalities. You have dramatic increases in population during the 25-year lull in activity. And you have potential, we were saying this before Katrina and all that stuff, have potential for massive damage, especially when the major cities are impacted, and large loss of life. This is what it looks like during the cooler years for major hurricane landfalls on the East Coast. This is what it looks like for warmer years in this historical record. Caribbean, cooler years, warmer years. Very, very different. In fact, if you look at the overall increases between these cool and warmer decades, it's huge. Since 1995, we're not talking about 2004, this started in 1995, overall activity doubles. Number of major hurricanes, 2.5 times as many, not stronger, but more. Caribbean hurricanes, 5 times as much. October, November major hurricanes, 10 times as many. Now, not 10 times each year, but we used to have them during the low activity year like once every 10 years. All of a sudden, we hit this upswing in activity. On the average of once a year, to get October major hurricanes. And this was published in the Journal of Science back in 2001. Got a lot of press, thankfully, because we were not saying this was from global warming. This was from natural variability. And there's other works that have come out by Bell and Chalaya up at the Climate Prediction Center that basically he looked at something called the tropical multidecadal mode. Very similar thing, and he looked, and if you compare that to the hurricane activity, it explained almost all the variance in the hurricane activity. And not that I expect you to absorb this one, but these are all sorts of different atmospheric variables that are associated with hurricane activity. And all of them just link up real tight to this multidecadal mode. So it's just like everything is in sync. When this changes, it's a very global mode. When this changes, it gets more favorable. All these things line up, and that's why the activity changes so much. Now, if you look at the previous chart, if you really look at it, you'll say, you know, it's a lot more active now than it was back then. You know, so why is it more active? And, you know, is it from global warming or is it from natural variability or both? And the battle is raging. I mean, we're in the middle of thinking there is name calling, there is threats, there is articles bouncing back and forth, talks bouncing back and forth. I mean, Lancey called one of the papers sloppy science. I agreed with him. But, I mean, they all blast, how could you call it sloppy? I mean, it's just going crazy with this. But the problems with using the historical tropical cyclone database is the non-homogeneity of the data. It's just not the same. It's temporally non-homogeneous, meaning with time, you have new observational platforms. Prior to 44, you only had ships, and they didn't always report, and they avoided storms. And you have then aircraft reconnaissance starting in 44, but even they constantly changed. And they're getting better and better how they're reporting. Improvements to land observations. We didn't have Doppler radar many years ago. And then finally you had the addition of the satellite observations starting about 1966, but even they're constantly changing. And then spatially non-homogeneous. In other words, not always measuring the storms all over the basin. The data quality varies tremendously between different basins or different parts of the same basin. Earlier, they depended on ship tracks. Then aircraft reconnaissance, and they didn't go out into the whole basin. They didn't fly if it wasn't going to affect land. They didn't fly out and measure things. In fact, there was no major hurricanes measured in a certain area north of about 25 north, east of 75 west before 1966. Not a single one. 66 must have been global warming. You know, all of a sudden you have these major hurricane tracks. I can imagine someone, if they find out, don't tell anybody, they'll do a paper on it. Okay, that's when we started the satellite coverage, and they started to say, oh, we do get major hurricanes in that area. Satellite coverage used to be far from uniform, and many of the alleged AGW-related increases or trend matched these changes in data measurements. So they're sitting there saying, look at this huge increase, and you've seen this in other talks, as yeah, look at how the data is getting so much better. I mean, anybody who knows the data, that's why I do not know of any scientist I don't know of any yet, at the Hurricane Center or the Hurricane Research Division that believe that the recent increase in activity is from AGW. They just don't because they know the data. Let me say what we said at the end of the science article. And we said that the tropical North Atlantic, and this is on the sheet, a handout back there, is exhibit a warming trend in the main development region of about 0.3 degrees Celsius. But the Atlantic hurricane activity has not exhibited a trend-like activity. We wrote this very carefully because we knew we were hitting a hot area with this to mention anthropogenic global warming or any kind of global warming or trend. The possibility exists that the huge activity since 95 is a result of the combination of the multidecadal scale change, and maybe this long-term trend is causing more. I'll just paraphrase this. But it's equally possible the current active period only appears more active because of the better observational network. And let me just skip past that a second. Therefore, I'll just say we warned, let me just go to the end here, that there remains potential for catastrophic loss of life. The government officials, everybody should pay attention. This was crying wolf, and you know what? We were right. It has just continued, and finally this increase in activity is the tracks have changed and started to hit the United States, and we've been saying this for years. This was right. This wasn't just a global warming yell. The recent disasters have not been a surprise. We're not shocked by what it does. Now I'm going to use my extra time he gave me to hit the real part of this. So, to go into what's the controversy. And I'll just, excuse me, whiz through this. I really apologize. I wish this had been better prepared and shortened down, but I'm going to just get through it the best I can. What is going on here? Okay, they're basically saying that various types of increases are being caused by these long-term trends, you know, in sea surface temperatures, and that this SST increases are caused by global warming. I'm just going to focus on the beginning because we're not dealing with whether it's anthropogenic or not. The focus is not just on increased activity in the Atlantic, but increased landfalls, major hurricanes in 2004. In other words, they sat there and said, look at all these major hurricanes hitting land, and they got all on the bandwagon. Well, the activity had already been going up for years, but this was a publicity thing. The tendency of some in the media, government, and certain scientific to attribute almost any increase in natural disasters to AGW. And this was just almost natural for them to jump on this. And the push by a few scientists starting in 2004, and I won't say their names, to announce the horrible landfalls were from AGW. I mean, they just got behind the media camera and said, this is global warming impact hitting us now. It was ludicrous. We were shocked at this. Nobody who really knew this data believed that. And then there were two pivotal articles that came out in 2005, and a lot more that followed that attributed huge increases to AGW in activity and got lots and lots of press. You go to the media and you say, this is from AGW, you know very well they're going to run with it. They're going to run with it. And you know, most historical experts, I've said this, don't feel it supports it. The science study used the least reliable type of data, the number of Category 5s, the absolute strongest storms, which we couldn't even measure well before. They started the sample at a low point in activity for two of the basins. So you started at a low point, there was high point before. They started at a low point, you get a trend. And we were looking at this, everybody was shaking their head at this. What are they doing? But they got published. Observation reporting methodologies, like I said, have changed greatly. And the basins, we don't go back and adjust all the previous years, though we're trying to reanalyze the North Atlantic. This just shows some of the stuff. This is the SSTs going up in some of the bases. This is from Webster et al. In 2005. And these are the different measures of tropical cyclone activity. The interesting thing is they found no trend, 1970 to the present, no trend in maximum wind speed, no trend in Cat 1s, no trend in Cat 2s and 3s. They kept going, 4s and 5s. We found the trend. Doubling, and that was their big finding. The Cat 4 and 5 storms have doubled. Now, if these were flakes out there that nobody knew, it was one thing, but these were reputable, known scientists saying this stuff, published in the Journal of Science. And the problem is that they started in 1970 because they started with satellite data, but the satellite data has changed tremendously through the years. A key thing was the Dvorak Technique. This was a method to analyze satellite data to get the strength of the storm. The infrared technique didn't start till the 80s, and they didn't institute it globally because we didn't have the web. People had to fly around and train people in the different basins to the late 80s. Now, the interesting thing, look at this chart, is after this point when they started Dvorak Technique, this flattened straight out. And I'm skipping this stuff right here. Just because it's published, I've said that. There have been comments published challenging things, so official published comments. Numerous other published articles that come against show the other. Thank you. That show the other. Findings have not stood up. There's a different thing besides peer review. There's peer discussion. I mean, there's scientists talking about it in emails, and because not everybody publishes, and there's meteorologists, there are weather stations that know sometimes more about than the PhDs on certain aspects, and they don't always publish, but they know when a thing is messed up. And people were going crazy when they saw these studies. Increased SSTs don't automatically mean more hurricanes. You got to change the atmospheric circulation, like I just said. The global climate models. Now, this is what they've shown, though. They showed that the vertical shear would increase with continuing warming, which would mean less hurricanes. And, this is, by the way, this is Kerry Emanuel. I read the whole thing. But Kerry Emanuel, who wrote one of these big studies and who is now all on the global warming bandwagon with this, before he did all this, he said if there was any increase from global warming, you couldn't even detect it. It'd be so small. And then he comes out with a paper saying double, triple. I mean, he really changed his tune. He said, I've converted. That was his great soundbite he would use for all the media interviews. Maybe it affected 1 or 2 miles per hour of Katrina's strength. Look at the difference in the observations. This is the incredibly active 2005 season. This is the 1933 hurricane season, which was incredibly active. Landfall after landfall after landfall. No storms in that area at all. You think just that maybe there weren't any storms, or we didn't measure it out there. We didn't have the aircraft. We didn't have the satellite. And in fact, you know what one of the papers did? When Chris Lancy came out with some of the stuff, they just went and said, well, you know what? What's happened is the storms have started to move more to the east with time. I mean, that was Greg Holland. It's like, where are these guys going? This is an incredible figure. This really shows it. This is from Chris Lancy, 1900 to the present. And what happens is he's showing the percent of the hurricanes, the percent of the tropical cyclones that are measured that are actually striking land. So back before satellite, there were years 100%. Every single storm that was measured hit land. And then all of a sudden you get satellites and never even near 100%. What does that say to common sense people? Maybe we didn't pick up the ones that weren't measuring land. No, not good enough for these other guys. They said, the distribution changed and everything like that. I'm going to just skip to what I want here because they're trying to get me off so the other speaker can that's actually a dupe slide anyway. Give me one moment. I got to say this with January, July. It's one thing if you sit there and say, a city, okay, the average temperature in this city over 100 years has gone up maybe half a degree. It's another thing if someone comes, doesn't know anything about annual fluctuation, hits the city in January, stays to July in New York, and says, you know how big your trend is? You know how much it's warming here? In 6 months, you'll be frying eggs on the sidewalk. They say, no. There's a cycle. And these guys are doing the cycle and getting these huge trends rather than this long-term reliable trend. And I can't go into them here now, but there's numerous other studies. They kept saying these huge increases. I'll just see if there's one of these I want to show. I mean, you show this, huge trend. You go back a few years, no trend. And let me just skip to something else. That's the Dvorak Technique. Oh, one thing with the East Pacific is, which is a very, very robust basin, is that the Hurricane Center took over the East Pacific in 1988. It used to be done by Redwood City. And all of a sudden, in 1988, you started to get a lot more of the stronger storms. I have these in numbers. It shows it better. I'll go right to the end, last slide. There's lots of it. What was hard is when I really started to prepare this, I realized how much there was out there. Other studies have shown no trend in landfall, which is the most reliable when you go back 100 years. Okay, there's my summary slide. The historical studies that carefully use reliable parts of the historical record find no discernible trend in any measurement of tropical cyclone activity in any basin or globally. The future model predictions have mixed results. They say either increased vertical wind shear, you might have fewer storms, but maybe stronger storms. Will this really verify? We'll see. How does it matter to you? I mean, does it really matter to people whether the storms are from natural variability or global warming? Really, day to day, we need to focus on preparedness. And just end with a gray cartoon. You know, everybody's worried about anthropogenic global, and here you've got this huge increase in landfalling hurricanes, and we're trying to get the attention on that. Thank you very much. Thank you for bearing with the rush here.